Hello everyone, this is our session 2 on definite integration. We've done around 6 properties of definite integration. 2 of them were remaining. So let us continue first with the properties and then we'll go down to the first exercise of chapter 4. Okay. So which were those 2 properties? Let's see those. Yeah. The property number 7, integral 0 to a f of x dx is equal to integral 0 to a f of x dx plus 0 to a f of 2a minus x dx. Okay, so if you have any limit, that is lower limit as 0 and higher limit as 2 of a, okay, a is a constant, any number, any value, then you can split it as 0 to a f of x dx plus 0 to a f of 2a minus x dx. Okay, we don't have to do the proof of the property, we learn it as a property and use it in our sums. Okay, next one, property 8, very important. Integral minus a to a f of x dx is 2 times integral 0 to a f of x dx if f of x is an even function and is 0 if f of x is an odd function. Now, how do we understand whether f of x is even or odd? So here they've given an explanation for the same. F of x is an even function if f of minus x, that is in place of x, we will put minus x and check if you are still getting the same function f of x. If you are getting that, then it is an even function. And if the function is even, then it gets transformed to 2 integral 0 to a f of x dx. If it's an odd function, that is in place of x, when I put minus x and I get a negative f of x, then the answer is 0. Okay, so these are the 2 important properties, last 2 properties that were remaining. Now we'll go on to exercise 4.2. Okay, so I'm going to do a few sums from this exercise so that we get well versed with the properties. Now, the main thing in these exercises that we need to know integration properly, that is basic integration that we have studied in the previous chapter. Okay, so let's start with the ones. Just 1 minute. Yes, so we're starting with exercise 4.2. Okay, I'll start with the second sum. I'm just picking up few random sums from this exercise to tell you the properties that we are going to use. Okay, so let's start with the first one, integration, second one, integration 2 to 3, 1 upon x square plus 5x plus 6 dx. Okay, excuse me. Yes. So basically, we'll start with the solution of the integration first, that is the quadratic that we have. So let us begin with finding the factors of the same. This will be x plus 3 and x plus 2. Okay. Now, how do we get the integration value of the same? So we are going to write this in the form of integral 2 to 3. In the numerator, we can write x plus 3 minus x plus 2, okay, divided by x plus 3 and x plus 2. So we're just getting the numerator in terms of the denominator, and then we'll separate the denominator. Okay, this is equal to integral 2 to 3. I'm now going to separate the integration as well. So this will be x plus 3 upon x plus 3 into x plus 2. Okay, minus integral 2 to 3 x plus 2 upon, don't forget the dx, very important, x plus 3 and x plus 2. Okay, so this was simple in integration at least. Okay, and then what you have to do is substitute the limits and get the answer. First of all, what is integral of 1 upon x plus 2? It is log of x plus 2. Okay, now that we will apply the limits to as lower limit 2 and upper limit 3 minus log of x plus 3. Okay, 2 and 3. Substituting the limits. So what do we get? You can substitute the high limit minus lower limit. So it will be log of 3 plus 2 upon log of, log of 3 plus 2 minus log of 2 plus 2. Okay, so I'll just do it for the first one. Log of 3 plus 2 minus log of 4, that is 2 plus 2, and then same way we'll apply for this, minus log of 3 plus 3, that is log of 6 plus log of 5. Okay, so our final answer for this sum will be log of So let's check what was in the previous frame. We had log of 3 plus 2 minus log of 4 minus log of 6 plus log of 5. Okay, so which can be written as log of one second. Yes. Log of 5 minus log of 4 minus log of 6 plus log of 5. Okay. So this final answer will be log of 5 upon 4 divided by log of which is log of 25 by 24. Okay, so this is the final answer. So that is how you would solve any sum, putting the higher limit minus the lower limit. Now here we could do one thing. I'll just show it to you in the next page. So we had log of x plus 2. Okay, right, we had log of x plus 2 as the first answer and log of x plus 3 as the second answer, right? And both limits were same. So what we could do is we could apply the limits in this manner also. It makes the sum simpler. So this will be log of 3 plus 2 minus log of, or even better, this can be written as log of x plus 2 upon x plus 3, right? Now this we'll apply the limits to 2 and 3. So that will be log of 5 upon, that will be 6 divided by log of not divide by minus log of the lower limit, that is 4 upon 5. Okay, log of a minus log of b again would be log of 5 by 6 upon 4 by 5, which will be 25 by 24. Yes, so simplifying the sum is in the way which you find simpler. Okay, you can first separately also find their answers. You can find the answer together also while substituting the limits. Okay, now I've taken the fourth sum, which is a trigonometric sum. Okay, so the fourth sum says integral pi by 4 to minus pi by 4 to pi by 4, 1 upon 1 minus sin x dx. Okay, so let us solve this. Now, how do we solve this? So, we're going to divide the numerator by 1 plus sin x. So, this will be integral minus pi by 4, 1 plus sin x, okay, upon 1 minus sin square x dx. Okay, divide numerator and denominator by 1 plus sin x, which will be integral minus pi by 4 to pi by 4. Okay, and this would be 1 plus sin x upon cos square x, right, dx. What we can do is send cos square x to each of the terms in the numerator, right? So that will be we'll put the integration outside, minus pi by 4 to pi by 4. In the bracket, we can put 1 upon cos square x, right, minus sin x upon cos square x, okay, dx, which is integral minus pi by 4 to pi by 4. Okay, cos square x will be sec square x. 1 upon cos square x is sec square x, minus sin upon cos is tan, and 1 upon cos is sec. So sec x tan x. Yes, and dx. Okay, so this integral value would be so this is of the form f of x minus f dash of x, right? So we can get the answer of this integral as tan x plus sec x. Both of them have an integral value. Formulas of integration should be perfect for this chapter. Okay, I told you we should be thorough with our integration, then limit substitution is the only thing that is left in this chapter. So we have tan of x plus sec of x as the integral value of sec square x minus sec x tan x. Okay, and then what do? Substitute the limits, higher limit minus the lower limit. So let us substitute this for this sum, which will be tan of pi by 4 plus sec of pi by 4, okay, plus, or this is your higher limit minus the lower limit. So minus tan of minus pi by 4 plus sec of minus pi by 4. Okay, now we should know that tan of a negative value is minus tan, and sec of a negative value, the negative sign disappears. Okay, so tan of pi by 4 is 1 plus, what is sec of pi by 4? Root 2. Okay, minus tan of pi by 4 is again 1 plus sec of pi by 4 root 2. Open the brackets. So we will have 1 plus root 2 minus and minus plus minus root 2. So the answer is 2. Okay, so I said it's just the substitution of the limits that should be perfect. Okay, I'm taking the next sum now, that is the 14th sum. Yes, so the 14th sum says integral 0 to 1 x tan inverse x. Okay. So all these are sums from question 1 of exercise 4.2. Okay, x tan inverse x, I is equal to this value. Let us try solving this. Now we are going to use this function that we know from integration, that is using integral u v dx. What is integral u v dx? U integral v dx, right? Minus integration dy dx of u integral v dx, right? Yes, so let us use this for our I value. So I is equal to u, that is, now here we are taking the first function as tan inverse, okay, because integration of x dx would be easy, and so that is why we are taking this as u and this as our v function. Okay, so u is tan inverse x, so tan inverse x, okay, integral 0 to 1 x dx. Okay, this is your first term, minus integration 0 to 1 du by dx. So d by dx of tan inverse x will be what? It will be 1 upon 1 plus x square. Okay, d by dx. Integral v dx, that is integration of x dx, and this whole thing dx. Okay, now what is integration of x dx? It is x square upon 2. So let us put this integration value here. So one part is at least solved. Integration x square upon 2. Okay, same way here also the integration will be tan inverse x into x square upon 2. Okay, do not forget to put the limits here. So the limit will be 0 to 1 minus, now x square upon 2 into 1 plus x square. So here we have to find out, what we can do is we can take half outside, and here we have x square upon 1 plus x square in the integration. That is, we have to find its integral value yet. We have not done this integration yet. Okay, and of course the limits are 0 to 1. Yes. So let us, you can substitute the limits for the first function at least. So that will be tan inverse of 1, that is pi by 4, and 1 upon 2. Okay, minus, it will be 0 because higher limit is 1, lower limit is 0. So the first, let's do the substitution and I'll show you that. So that is tan inverse of 1 into 1 upon 2. This is your higher limit, minus lower limit, that is tan inverse of 0 into 0. Okay, so this entire term becomes 0. Now the second part of this sum we have not yet solved, minus half integral of 0 to 1 x square upon 1 plus x square dx. Okay, this integration we have yet not solved. So this answer will be pi by 4 into half, that is pi by 8. Okay, minus half as it is. What is integral of 1 upon, or rather x square upon 1 plus x square? You'll write this as x square plus 1 minus 1 upon 1 plus x square. And then what do we do? Separating the denominator. Okay, so which will be pi by 8 minus half bracket. We can integral 0 to 1, 1 upon, so it will be 1 plus x square upon 1 plus x square minus integral 0 to 1, 1 upon 1 plus x square dx. Okay, so here this will cancel out and you will have pi by 8 as it is. This is the first part of the integral, minus half as it is, bracket x 1 dx, answer is x. Okay, minus what is 1 upon 1 plus x square? It is the integral of tan inverse of x. Okay, and so for this entire thing, we'll substitute the limit 0 to 1. So the final answer to this one will be pi by 8 as your first term minus half, and then in the bracket we have, let's substitute the integral value. So 1 minus tan inverse x, that is tan inverse of 1 minus pi by 4. Okay, and about the 0, you'll have minus 0 minus tan inverse of 0. Okay, so you'll be left with only this much in the answer. You'll have pi by 8 minus half plus pi by 4. Okay, which will be pi by 8 plus pi by 4 would be 2 pi by 8, that is pi by 4 minus half. This is your final answer. Okay, so that is your question number 14 that we just finished. Now I'm doing one more of this, that is integral x e inverse x, that is e raised to minus x dx, exponential function. So it's a different type, that's why I'm solving this. Integration 0 to infinity x e raised to minus x dx. Okay, so let us solve this integration first. I'm again using u integral v dx, so I've taken u as x now. Integral e raised to minus x dx. Okay, 0 to infinity minus integration of 0 to infinity d by dx of x integral e raised to minus x dx, and this whole into dx. Okay, which will be equal to integration of e raised to minus x will be e raised to minus x upon minus 1, 0 to infinity. Okay, plus, okay, there's a minus sign here, we'll put the minus as is. Integral 0 to infinity as it is, d by dx of x is 1. Integral is e raised to minus x upon minus 1 dx. Okay, so yeah, there is a double integration here. You can see that we take this integration first, then there is a dx again, so we'll integrate this value again. Okay, so let us put the limits in the first part, and for the second one we have to write the integration again. Okay, so for the first one it will be minus x upon e raised to x 0 to infinity minus integral 0 to infinity e raised to minus x dx. Okay, so this will be equal to, now let us substitute the limits in this. So this will be 0 minus of minus 0. Okay, minus integral, okay, here we have to find the integration yet, so let's put the value of the integration. Value of the integration is e raised to minus x upon minus 1, 0 to infinity. Okay, so the final answer would be, this part is 0 here, minus it will become plus with this minus, and e raised to minus infinity okay minus e raised to 0. Okay, so which is equal to 1. Now how do we get this 1? So since e raised to 0 is equal to 1, okay, and e raised to minus x is equal to 0 when x is infinity. So basically e raised to minus x is 0, and here we have a plus sign, because when you open the bracket with this minus sign and the limit value, it will become plus. So the answer is 1. Okay. That's exercise 4.2 question 1. We'll do the remaining ones in the next session. If you have any doubts regarding any of these sums, do let me know. Thank you very much.